Hello everyone, I am Sadhil Chhabra. I am currently in third year and pursuing B.Tech Computer Science from Bennett University. Today I am here to present a seminar on the topic NFC and Future. My mentor is Dr. Rajendra Chaudhary. So let's start.
I am sure that most of you are already aware of this technology, and many of you might have used this technology in your smartphones or tablets for sharing the photos with friends, and perhaps you might have used this technology for pairing the Bluetooth speakers and smartwatches. In fact, because of this technology, we can use mobile payment services like Google Pay, Samsung Pay, and Apple Pay. Now we come to the overview section. So today we will know about what is NFC, history of NFC, its working, different communication modes, different modes of operation, some NFC standards, uses of NFC. We will compare NFC with some existing technologies, then advantages and disadvantages of NFC, and finally the future scope of NFC. Now, what is NFC? NFC stands for the Near Field Communication, and as its name suggests, it is a short distance wireless communication technology. So, when two NFC enabled devices are very close to each other, roughly around 4 cm, then they can communicate with each other using the radio waves. Now, out of the two communicating devices, at least one device has to be an active device, like smartphone, tablet, or the payment terminal, while the other device can be active or passive. And the example of the passive device is the NFC tag. Now, here the active device means the device which requires the external power supply, while the passive device does not require any external power supply as it is powered by the electromagnetic waves of the active device. Now, let us discuss about the history of NFC. In 2004, companies like Nokia, Sony, and Philips acknowledged the NFC forum. Then in 2006, initial specializations and mandatory tag format support for NFC was announced, and in the same year, that is 2006, first NFC phone was released by Nokia, that was Nokia 6131. In 2009, in the month of January, NFC forum released peer-to-peer standards to transfer contact, URL, initiate Bluetooth, etc. Then in 2010, Samsung released its first Android NFC phone named Samsung Nexus S. In 2013, Samsung along with Visa announced their major partnership to develop mobile payments using NFC. Now, let's talk about that how NFC works. As with proximity card technology, near field communication uses magnetic induction between two loop antennas located within each other's near field, effectively forming an air-4 transformer. NFC always involves an initiator and a target. The initiator actively generates an RF field that can power a passive target. This enables NFC targets to take a very simple form factors such as tags, stickers, key fobs, or cards that do not require batteries. NFC peer-to-peer communication is possible, provided both devices are powered. NFC is a set of short-range wireless technologies, typically requiring a distance of 10 cm or less. NFC operates at 13.56 MHz air interface and at rates ranging from 106 kilobits per second to 424 kilobits per second. According to the theory, NFC's working distance with compact standard antennas is up to 20 cm, but practically it has a working distance of about 4 cm. Now, here we will know about the communication modes in the NFC devices. So there are two communication modes, that are active communication mode and passive communication mode. First we come to the active mode. As you can see here, in this mode, two NFC enabled devices are transferring data. In active mode, both the devices, that is the initiator and the target device, communicate by alternatively generating their own fields. Another point is that a device deactivates its RF field while it is waiting for data. In this mode, both devices typically have power supplies. Now, we come to the passive mode. As you can see here that an NFC enabled phone is paired with a RFID tagged smart poster. In passive mode, there is only one active device and the other uses that field to exchange information. The initiator device provides a carrier field and the target device answers by modulating the existing field. In this mode, the target device may draw its operating power from the initiator provided electromagnetic field, thus making the target device a transponder. Now, we come to the modes of operation for the NFC devices. NFC supports three modes of operation, namely read-write mode, peer-to-peer mode, card emulation mode. Now, here firstly we will talk about peer-to-peer mode. In peer-to-peer mode, two NFC devices can exchange data. For example, you can share Bluetooth or Wi-Fi link, set of parameters, or you can exchange data such as virtual business cards or digital photos. Another point is that in peer-to-peer mode, both devices are active devices and they can communicate with each other by generating the radio waves alternatively. It means that when one device transmits the data at that time, the second device only listens to it and it does not generate its own radio waves. Similarly, when the second device transmits the data, at that time the first device only listens to it and it does not generate its own radio wave. Now, we come to the read-write mode. In this mode, we can access the data or information using the smartphone from the NFC tag. So, this mode of operation is very similar to the RFID, that is radio frequency identification. So, in this mode, the active device like smartphone or tablet reads or writes data on NFC tag using the principle of electromagnetic induction. Now, to read the information from the NFC tag, the active device generates the radio wave at the carrier frequency of 13.56 MHz. So, these waves used to get coupled to the antenna of the passive, and from this electromagnetic waves, NFC tag receives the power. So, this time-varying electromagnetic field generates the EMF for the voltage in this passive tag. So, this generated voltage is rectified using the rectifier and it is used to power up the chip inside this NFC tag. Now, this small chip generally comprises the clock, EPROM, rectifier circuit and the small controller. So once the chip is powered up, then the tag responds back to the active device by the technique which is known as the load modulation. So in this technique, the tag uses the internal clock of the chip and it generates the auxiliary carrier frequency of 848 kHz. Now depending upon the stored data inside this chip, the load which is connected in parallel to the antenna is turned on and off. And in this way, the data is sent back to the active device. So in this way, by the principle of electromagnetic induction, the passive tag receives the power and using the load modulation, the data is sent back to the active device. So this is all about the read and write mode. Now, at last we come to the card emulation mode. So, the example of this mode is when the smartphones are used for the mobile payments. So, in this mode, both devices used to be the active devices. Generally, the one device used to be a smartphone and the second device obviously used to be a payment terminal. But in this mode, the smartphone acts like a passive smart card. So they do not generate their own radio waves, but they only respond back to the requested data by the payment terminal. Hence, the smartphone acts like a passive device and the operating principle of this mode is very similar to the reader or writer mode. So, these are the three supported modes of operation by the NFC. Now, in this NFC, some standards are defined to establish the communication between the two devices, and in these standards, certain parameters are defined, like what should be the operating frequency or the carrier frequency of the radio waves, what type of coding scheme should be used, what modulation technique should be used, and what should be the data rate for the information sharing. So, these standards are derived from the already existing standards which are used for the radio communication, and these standards are known as the NFC A, NFC B, NFC F and NFC 5. So this is the table which summarizes some of the parameters which are defined under these standards. So that is being said, now let us see some useful applications of NFC. Now let us talk about some useful applications of NFC. Already many applications are known to us. In fact, we are already using this NFC for these applications like for file sharing, for mobile payments, for pairing different devices and for information sharing using the smart posters and the business cards. But apart from that, it can also be used for the home automation, for healthcare, in library systems or even for personal usage. So at home, just by tapping the NFC tag using the smartphones, we can change the brightness for the ambient light, or it is also possible to change the temperature of the air conditioner, or even we can automatically close the doors using this NFC. So these are some of the applications that how NFC can be used in our home. Similarly, in the healthcare department, just by tapping the mobile to the patient's NFC tag, you can get the required information and the history of the patient very quickly. Moreover, these NFC tags can be used for the personal usage. Like just by tapping the NFC tag, we can change the setting of our smartphone. Just by tapping the NFC tag, we can turn on the Bluetooth or Wi-Fi of our smartphone, or we can even open a particular app or game in our smartphone. So these were some useful applications of the NFC. Now, let us compare this NFC with different technologies like Bluetooth, RFID and QR code. So, first let us compare this NFC with the Bluetooth. Bluetooth is also a wireless communication technology, and using this we can share the information and various files among different devices. In fact, the data rate at which the information can be shared on Bluetooth is quite high compared to NFC. But in case of Bluetooth, the time that is required for pairing the devices is more compared to NFC. In fact, in NFC, the two devices can be set up in less than 0.1 seconds. And that is why today, in many devices, NFC is used for pairing the different devices. And once the pairing between the devices is established, then for communication, either Bluetooth or Wi-Fi is used. Now, let us compare NFC with the RFID. So, this NFC is derived from the RFID standards. In fact, the working principle of NFC is quite similar to the RFID. But this RFID technology works on different frequencies, starting from the low frequency up to the ultra high frequencies. But NFC works on the particular frequency band, that is 13.56 MHz band. So this is one difference between NFC and RFID technologies. Now in case of RFID, the reader sends the request to the RFID tag, and in response, the RFID tag replies back to the reader. So here, as you can see, that there is only one-way communication possible in case of RFID. While in case of NFC, it is also possible to have a peer-to-peer communication. That means two devices can communicate with each other alternatively. So this is the difference between the NFC and the RFID technology. Now let's compare NFC with QR code. So this QR code technology can also be used in some applications where these NFC tags are used. For example, using this QR code, we can open some applications or we can provide some additional information to the customer about the product. So in a way, this QR code can also be used in the place of NFC tags. But to access the information, we need to scan this QR code using the mobiles. While in case of NFC, just by tapping the mobile to the NFC tag, the information can be easily accessed. So we can say that the access time which is required in case of NFC is less than the QR code. Moreover, this NFC is more secure than the QR code, because in case of QR code, it can be replaced by putting another QR code on top of it. While in case of NFC, if someone puts another NFC tag on top of the original NFC tag, then neither of the tags can be accessed. So, in a way, NFC technology is more secure than the QR code technology. Now, let's discuss the advantages of NFC. It is very convenient to perform payments and other transactions using smartphones with the help of a wallet app. It is used for multiple applications in various domains such as banking, reservations, booking tickets, redeeming, entry-exit passes, etc. It helps both customers and enterprises. It provides secured access for students and employees in their premises. It provides more security compared to the magnetic strip-based debit and credit cards. It also uses PIN. It does not require search and pair procedure like Bluetooth and other methods to establish connectivity. No special software is needed. Moreover, it does not require manual configurations and settings. It is also compatible with the existing RFID networks. Now, the drawbacks of NFC are: it can only work in shorter distances, which is about 10 to 15 centimeters. It offers very low data transfer rates. It is very expensive for the companies to adopt the NFC enabled devices. It is not so advantageous for users due to the complex procedures when compared to other easy options. Though it is more secure compared to credit or debit card based system, but it is not completely risk free. This is due to the fact that mobile based hacking is common nowadays, due to the availability of most advanced tools and techniques which provides complete access of smart devices. Also, the power consumption is comparatively more in NFC enabled devices. Now we come to the future scope of NFC. NFC based sensing is still in its infancy. The potential of NFC to enable entirely new sensing concepts will likely play an important role in the future of the connected technological revolution. Challenges remain to be addressed, however, particularly in terms of materials and manufacturing, to turn laboratory prototypes into commercial products. Interestingly, the current COVID-19 pandemic stresses the need for contactless interactions beyond payment systems. the effect of which will likely accelerate NFC-based sensing technology. Moreover, because data security is at the core of NFC-based sensors may be paired with high-security technologies such as blockchain to create trusted, automated, and connected sensing systems. This combination would improve integrity, accessibility, and speed of operations with food and healthcare systems. Moreover, the global NFC market is expected to reach about $49.5 billion by 2025. Yes, NFC is going strong. More and more options will get explored, allowing for our lives to get easier in new ways. NFC payments are already a thing. Consumers are comfortable with using NFC in general and will welcome its further integration into their daily lives. They've already seen the speedy transactions and the effortless payments, and they want more. Top brands also welcome NFC as a way to connect and communicate with customers, and more will soon follow suit. The corporate world is infamous for being conservative. If they are also adopting this tech, you just know it's about to become mainstream. Now, what is NFC? Now you know the answer. We also discovered how NFC works, and much more. NFC might seem like a boring acronym, but we now witness to how cool this technology is. Be it in the bus or the train station, the retail store or the supermarket, the movie theater or the gym, your car or at home, the technology is just a tap away. So, this is it from my side. Thanks for watching the video. Hope you liked the session.